something, 151. Okay, welcome back. Happy Friday. Today we are going to cover something called factoring out the greatest common factor and factoring trinomials. Now, a couple of things. First of all, coming up on Monday, we have quest number 3. That quest is on classes 14 to 18. This is class 19, so the stuff we're doing today, not on the quest. You've already seen the stuff on the quest. Also, I have heard that there is some weather heading our way this coming Monday. I'm not going to say the S word in this class, but if it happens that we are not here on Monday because of weather, then that quest will happen on Wednesday, okay? So just plan on taking it the next time we are here officially when GCC is open. Also, the factoring out the GCF we did at the end of last class. We stole time last class, so we'll just review that very quickly and then jump to the harder part, the factoring trinomials part. So let's give this a shot on page 151. Just refreshing our memory that the word factor means turn into multiplication. And so we saw this first example here, 21x squared minus 15x. That is fundamentally a subtraction, but we were somehow able to turn it into a multiplication, right? Like these two expressions were equal to each other, but one of them was multiplication. That's what it means to factor. This kind of factoring that we did right here is called factoring out the greatest common factor. We're going to see a number of factoring techniques over the next few classes. Factoring out the greatest common factor is the first thing to try on every factoring problem, every single one. So let's just briefly review how we solved this problem here. We were given the thing in yellow, this yellow highlighted thing here, and we were trying to factor out the greatest common factor. And so what we needed to do is figure out what that greatest common factor is. And we had this long process that we wrote out that is not mandatory, but it's a process you could always follow, where we looked at the numbers, the -12, -28, and 8. Hopefully we have some miracle and can figure out what the greatest common factor of those numbers is. It was a 4. And so then we took each of those numbers and wrote them as 4 times something. So for example, -12 was 4 times -3. 4 times something, 4 times something. And then we just wrote out all the variables. X squared, we wrote 2x's multiplied. Y to the 5th, we wrote 5y's multiplied. And then we looked and we said, okay, let's circle everything that's in common to all 3 terms. The terms were separated by pluses and minuses, which we wrote little squiggles for. And we said, okay, they all have a 4. We built that 4, so we circled all the 4s. They all have an x squared in them. Some of them have more x's. But how do I know x squared is the most we can take out of all of them? Because it's the least amount of x's that we see. And so x squared got circled, and then we looked for as many y's as we could find, and y cubed was the best we could do, again, because y cubed was the least amount of y's in any of them. And then whatever we circled for all 3 of these little sections is exactly the same, right? We've circled 3 copies of the same thing, and all of that stuff that we circled right in there is the greatest common factor. So 4, x squared, y cubed was the greatest common factor. And so we put that greatest common factor on the outside of some parentheses here, 4x squared, y cubed. And then what goes in the parentheses was just the stuff that we didn't circle. And so in the first, before the first squiggle, -3, y squared, that's what we didn't circle. That's what goes there, right? And so it's just it's kind of a long drawn out process the way we've done it here. Hopefully with practice, like in tonight's homework, you'll get better at it and get to a point where you don't need to write it out. But if you never get to a point where you don't need to write it out, it's okay. Just got to get to the answer. Writing it out will get you the answer. But if you don't need to write it out, then don't write it out. Okay, let's take a look on the next page at number 8. 152? Yeah, 152. Okay, here's one that's tougher. Factor -2x cubed plus 8x squared plus 24x. That's the problem. This problem is going to take us a long time. First, we'll factor out the GCF, greatest common factor. This will always be the first kind of factoring to try. At the moment, it's the only kind of factoring, but even though we're going to have all these pretty new tools pretty soon about factoring, that's always going to be the first thing to do. So let's give it a shot. Here's the original problem, -2x cubed plus 8x squared plus 24x. I just put it in a box, right? So we've got 3 rectangles there. We're not going to write this one all out. But again, you can separately if you want to. But let's just see if we can kind of build our intuition, doing this one without writing everything out. So let's just look at the numbers. -2, +8, +24, and ask ourselves, what's the biggest thing that goes into all of them? 2. So the biggest thing in all of those is a 2, and so I'm going to put a 2 right out front there. And then I'm going to look at the variable. I've got x cubed, x squared, and x. I'm going to take out as many x's as I can, but as Evan reminded us, you can only take out the fewest number of x's you see anywhere. So what can I take out? Just x, just a single x. And so we're going to take out a single x there. And we know that the way that our box works is that each of the things inside of the box, for example, this guy right here, represents an area. That one is the area of this rectangle, right? And we know that area is length times width. And we just figured out the width of this box, that rectangle, is 2x. And so we got to fill in something up above so that when I multiply 2x and this unknown up above, I get the -2x cubed. So this is just thinking of our box backwards, right? The problems we've done with the box so far, we've been given all the stuff outside and we filled in the inside. Now we have the inside and we're filling in the outside. So we just have to figure out what we need to multiply. What can I put up here? Let's see. I've got a 2 there. I've got a -2 here. But just a negative, right? I got to somehow resolve that negative. I have a single x outside, but I have an x cubed inside. X to what power? It's x to the 2. It's like filling in what's missing. And if you don't see that, well, let's just check. If you multiply this and this, you should see that you get -2x cubed, which is exactly what we want. Yeah? Fill in the stuff above the other 2 arrows for me. Okay, let's check in here. So I've circled one of these guys in blue. How am I going to build the 8? What's missing from the 2 to build the 8? It's 4. I'm going to ask you to say one more thing. +4. That's what's missing. And I've got an x outside, but I needed x squared inside, so a single x up on top. And again, you can always check, just do the multiplication. You should get what's inside of the rectangle. And then finally in red, 2 is supposed to turn into 24. How do I make that happen? Is by multiplying by +12. And what about x's? I don't need any because there's a single x inside and it's already accounted for outside. So we're good to go. This is an alternate to writing everything out, is to use the box. You have to do some stuff by inspection. You have to have some intuition that you built up. You might build that intuition by writing it out lots of times, but eventually maybe feel comfortable here. Okay, so here's what we know. We know that the original problem, that was this guy, is equal to a 2x on the outside there times all of this stuff in parentheses. And that's what's written there. Everybody okay? That's what factoring out the greatest common factor looks like. Pull the thing out in the front, everybody else in the parentheses. And again, of course, you could always check because we know we're supposed to distribute here. And if you distribute, we will get exactly what we started with. So far, so good. All right, now we're going to look at the thing in the parentheses. It turns out that we can factor that thing farther. Now, we can't do the greatest common factor anymore because the greatest common factor of the 3 things I just highlighted is 1. There's nothing else that goes into all 3 of those things other than 1. You could always factor out 1, but that doesn't ever change anything. So it's just a brand new kind of factoring that we're after here. And this is going to be hard. So we're going to factor this thing in green using the box. It's going to be a 2x2 box, which is going to make things much tougher. Fair warning, what we're about to do is one of the toughest processes of the whole semester. But we're going to do it. First, we're going to refresh our memory on how to use the box to multiply 2 binomials. That word binomials, we know bi as a prefix means 2, right? So here's a binomial because it has 2 terms. Here's another binomial because it has 2 terms. So multiplying 2 binomials, let's use the box. Everybody put a 3x and a -4 out there. And up above, 2x and +5. And then the way we use the box to fill in the box is to just multiply. And so that guy right there is a 6x squared. Go ahead and fill in the other 3 rectangles. How are we doing with the multiplying 2 by 2 box? It's okay. And so that means that when we multiply these 2 guys together, we get just what's in the box. So I'll just write it all out across the first row and then across the second row. And then finally just combine terms. Which terms combine? Yeah, the 15x and the minus 8x give me 7x. Okay, so that's just a refresher, how we multiply using a 2 by 2 box. And a couple of observations. Let's make some observations. Okay, first observation. If you add these 2 things together, what do you get? 7x. So far, so good. Just pointing it out, that the 7x comes from adding that diagonal right there. Okay, here's another observation. If you multiply these 2 things together, I'm going to write the word product here. What do we get when we multiply that? Negative 120 x squared. You guys just write those 2 things right below the box. When we multiply that red diagonal, we get negative 120 x squared. And then the last observation is I want us to multiply the 2 things in green. What do we get when we multiply those 2 things in green? 15x and negative 8x. What do we get? Close. Negative 120 what? X squared. Yes? When we multiply that diagonal, we get exactly the same thing that we got when we multiplied the other diagonal. This is a surprise. Should be a surprise anyway. Right? I was surprised the first time somebody showed it to me. Really? Get out of here. I didn't know that. Turns out it's always true. When you multiply 2 binomials using the box, whatever you get when you multiply the one diagonal is going to be exactly the same as what you get on the other diagonal. We're going to put all of these observations together in order to factor this thing up here in green. The ultimate goal with this thing in green is that it's supposed to look like 2x, and then the thing in green is going to get factored into 2 parentheses, and just like the 2 parentheses right there. Because when we multiplied these 2 parentheses down here, we got some x squareds and we got some x's and we got a constant, right? And the thing in green is some x squareds and some x's and a constant. So maybe, just maybe, if we fill in these 2 blue blank parentheses correctly, we'll be able to build that thing that's highlighted in green, right? At least it looks like stuff that comes out of multiplying with the 2 by 2 box. All right, move on to the next page. It says, now suppose we're trying to factor 6x squared plus 7x minus 20. Using the 2 by 2 box at right, where should we put the 6x squared? Where would the 6x squared go? In which of those 4 rectangles? Top left. Because we know, I'm not going to write the answers out here, but like if this is a 5x minus, don't copy this part, and this is a 3x plus 1, and you multiply this and this, that gives you your x squared thing, right? It's not 6x squared, it's 15x squared for this example. But we know the x squared thing is always going to end up plopped up there in the top left. So the 6x squared is going to go there. What about the negative 20, which was that last guy? Where did the negative 20 appear in the box on the previous page? Bottom right. Negative 20 went right there. The other 2 boxes are tough. The other 2 boxes, if you look at the previous page, were a 15x and a minus 8x. Is that right? Okay, I don't know where they came from because they certainly aren't in the original problem, this 6x squared plus 7x minus 20. Somehow we need to build the 15x and the minus 8x. But at the very least, 6x squared and minus 20 should go right in there. And then it says, what should the product of the top right to bottom left diagonal be? Top right to bottom left. Well, okay, so what do we get when we multiply those two blanks? Well, I don't know, they're blank. But I know that whatever the product is there is the same as the other product, right? Two products, the two diagonal products are always equal. So the product going that way has to equal the same as the product going this way. So the product going this way, we've already done it. Product is that negative 120x squared. And so whatever I put in the green has to multiply to negative 20x squared, negative 120x squared. And what about the sum? How can I know what the sum of the two green things is supposed to be? They're blank. It's the same as adding the other? No. Yeah, so the product is for sure the same. But what about the sum? Has to equal what, Jameson? 7x. Because I know that after I combine those two blank boxes in there, they have to give me the 7x. That's the goal. And so that's where the 15x and the minus 8x come from. It's tough, but these are facts that you can build. This is the backwards direction. Okay, so let's see if we can apply it to a problem where we didn't already have the answer. So we're here in number 11. We had that guy right there, and we factored out the 2x, and we were left with this thing here, which I will again highlight in green, trying to factor that thing in green. So coming down here to this box, we're going to put a negative x squared. That is this guy right here in the top left. It's already done for us. What about the bottom right? How do we find that number? All you have is the green. So how do, yeah, the one at the far right, right? That number without any x's has to go in the bottom right box. We know that we can multiply these two guys that we've just filled in, and it's going to be the same product on the two blanks that we don't know about yet. We also know that the sum of the two blanks is supposed to equal what? Again, all you have given is that thing in green. It's supposed to be that 4x. Everybody okay with the pieces? So here's the hard part of this process. It's mechanical to this point. The hard part is finding two things to put in those blank rectangles whose sum is 4x and whose product is negative 12x squared. That's where we got to be detectives. Some of you might be able to tell what those two things are, multiplying to negative 12x squared and adding to 4x. Whether you can see what they are or not, we should all be going through the same thought process. Should we start with things that add up to 4x and then check to see if they happen to multiply to negative 12x squared? Or should we start with things that multiply to negative 12x squared and see if they happen to add to 4x? Why? It is going to be the same product on each side, that's true. That's the key right there. It is easier to find factors of negative 12 than to find things that add up to 4. Factors of negative 12, there's not that many, right? Like 1 and 2 and 3 and 4 and 6 and 12. I just listed all of them. All of the factors of 12. But how many things can you think of that add up to 4? Infinitely many. 0 and 4, 1 and 3, 2 and 2, negative 25 and positive 29. Yes? So which one should we start with? We should start with the factors because that is a small number, a finite number, right? Don't start with the sum. So we're going to start with factors of negative 12x squared. Now I've done the work for you here. I just listed them all. That column right there, factors. That's all the things that multiply to negative 12x squared. Notice that each of them has an x in it. Because we know the two things in the blanks are supposed to just have x. They're not x squareds in the blanks, they're just x's. So I've listed all of them. There's only 6 possibilities. And now we're just going to add up. We're just going to find the sum. We're going to cross our fingers. Eventually we find something that adds to 4x. But it's not that long of a process. So adding 1x and negative 12x is negative 11x. go ahead and fill in the other 5 blank sums, just adding up. Okay, so we've got 6 sums. We are hoping that one of them is the sum that we were after. Do we see it? Which one has the right sum? The second to the bottom, 6x and negative 2x. Let's make sure that they satisfy the things that we were hunting for. They were supposed to multiply to negative 12x squared. Do they? They do. They were supposed to add to positive 4x. Do they? They do. We were good detectives. So we're going to take the 6x and we're going to take that negative 2x and we're going to put them in the box in the empty rectangles. It makes no difference which one goes where, but let's all put them in the same spot so we can all be looking at the same thing. Let's all put them in this order. I'll put a negative 2x in the top, negative 2x here, positive 6x down there, okay? Again, doesn't matter what choice you make. All right, so the box is filled in. Now we're trying to find the stuff that goes outside the box. What did we multiply outside the box that built those 4 things inside the box? Here's how we do it. We're going to look in the first row. You can pick any row or column, but I'm just going to always start on the first row just to be consistent. I'm going to pull out the greatest common factor of this first row. Okay, looking at the numbers, what can I take out of both of those things? You can take out an x for sure. Let's put an x out there. And let's put a negative out there because there's a negative in everything in the first row. Okay, so we factored out the greatest common factor in the first row. Don't write down the following, but let's do the same game in the second row. Let's factor out the greatest common factor in the second row. What number goes into both? Positive 6, right? Can you take an x out of both? No, so just positive 6 is what's going to go down there. Now it turns out that just positive 6 is the right answer, but doing what we just did will sometimes give us the wrong answer. So what I don't want us to do is just take out the greatest common factor of every row and the greatest common factor of every column, because you will sometimes go wrong. Sometimes you'll be okay. In this one, you'd be okay. But I want us to have a process that's going to work every single time. So the only greatest common factor we're going to pull out is the first row, and the other 3 blanks outside the box we're going to fill in a different way. We're going to go back to first principles and just say, okay, how does the box work? We know we multiply a length and a width and we put it someplace in the box, right? So let's just work backwards here. I can figure out what goes up there because I know that whatever I put on top multiplied by this negative x is supposed to be negative x squared, yes? So what can I put up on top so I have the right product in here? X, right? Because then we multiply and we get negative x squared. Let's play the same game over here. I'm going to temporarily highlight in green. I know that that times whatever I put in the blank is supposed to multiply to the negative 2x, right? What do you have to put up there? 2. Let's include the positive sign when we write it down. So we're going to put a positive, oopsies. I'm going to put a positive 2 out there. Okay, now we need to change our focus. I'm going to look at the 6x. And I know that the 6x came from multiplying 2 things. It came from multiplying these 2 things, that guy and this blank, yes? So what does the blank have to be to build that positive 6x? Positive 6. So we'll put a positive 6 out there. Which, by the way, is the greatest common factor of that second row. It's what I had said don't copy down before. We got it right this time, but we wouldn't every time. Okay, there's one thing in the box that we didn't look at. Which one? 12, and we have no more control over what goes outside. Outside is already filled in. So we better check and make sure that the miracle happened and we got the right product. Did it work? That guy times that guy is supposed to be positive 12, is it? It is. And as long as you follow all the steps correctly, it will be. but it's a good chance to catch a careless error someplace and then go back and try to find it. Okay, so I think we are golden here. What that means is that this thing here in green, which I'll copy here, negative x squared plus 4x plus 12 is equal to 2 parentheses multiplied together, and it's just the stuff that we built outside of that box. I'll read the stuff on the far left, negative x plus 6, and then multiplied by the stuff on the top, x plus 2. It's okay to write the parentheses in the reverse order. Doesn't matter which one goes first. I'm hesitant to ask this. Are there any questions? Like with most things in life, it's easier with practice. I promise it will get easier with practice. The last piece of this puzzle here, there was a 2x sitting on the outside from way back when in this problem. Where do you think we're going to put the 2x in the final answer? Just outside. Just put it right in the front. I won't rewrite it. It's on the next page, I think. Here. There's our final answer. Okay, so we're going to do that same problem one more time, quicker and kind of in a more organized fashion. This is the first time that I have used this particular setup here. See all these crazy numbers going on? It's an idea I came up with in the middle of last semester, but I didn't show it to anybody. You guys are the first ones, so at some point I'll ask you if it works for you, but feel free to ignore it if it doesn't work for you. It's the same picture. It's the same 2x2 box, but I've just put some blank lines floating around where we got stuff that we're going to fill in. So let's copy the original problem. The original was this, negative x squared plus 4x plus 12. And we're just going to do this entire problem from scratch, but quicker using this template. So negative x squared plus 4x plus 12. That is 1, 2, and 3 things, and we're going to put them into the right spots that are labeled 1, 2, and 3. Number 1 is up here in the top left. Okay, that jives because we know the x squared term always goes up there. Number 2 doesn't go inside of the box. 2 is quite a complicated part of the problem. 2 turns out to be the sum. So it goes down here in the sum. I like including that sign. So plus 4x down there is the sum. And then where does 3 go? Bottom right. We know the number without x's goes in the bottom right. Again, include the sign. That's a positive 12 down there. 1, 2, 3. Right? They all have a home. What's the fourth thing we're going to do? Look for the 4 in the picture. Right. We're just going to multiply that diagonal. And what do we get? Negative 12x squared, right? Just multiplying those two things together. So we've got 4 things filled in. That's the mechanical part of the process. The next step is the most thought-provoking part of the process, because here's the detective work. We're looking for 2 things that multiply to negative 12x squared and add to 4x. You can do an ordered list, but at some point you need to come up with the miracle that is those 2 things. What are those 2 things? Yeah. This is what we discovered by listing all the possibilities, right? And so then we put those 2 guys in the next spots. We've just done number 4 as the product. So 5 and 5 is in 2 spots. Just grab those 2 things and put them in the box. Again, it doesn't matter where you put them, but can we put them in the same places we put them before? Where was the 6x was in the bottom, right? So 6x down here, negative 2x up there. That was the 5th thing we put in. Now we put in the 6th thing, which you can see is placed outside of the first row. And so we look for the greatest common factor in that first row. What is it? It's the negative x. But that's the only greatest common factor we're doing. Everything else is multiplying, figuring out what do I need to multiply to build what's in the box. And so up here, number 7, I'm just going to point, and I'll try to use my marker here. 7 times 6 is supposed to equal that guy, right? Just got to imagine the arrows. So what goes out there is an X. Then we look at number 8. We know that 8 is building this guy. So 6 times 8 is supposed to be that. What's 8? -2, right? Nope. +2. Multiplies to give me the -2x. And then finally 9. 9 has a lot to do with this guy. So 9 times 7 is supposed to be this guy. So what's 9? +6, right? Plus sign there. And of course you should check. 2 times 6 gives you the +12. So again, brand new. Use it if it feels like it's a good way to keep your thoughts organized and kind of know where to go. Like I said, it's a long process, but gets easier with practice. Okay, so you're going to do the activity starting right now. And you're going to make a note, maybe right now or someplace that you see it, that when you do the homework on My Math Lab, you're going to use this 2x2 box method for at least half of the factoring problems. The book, the My Math Lab homework itself, which I did not create, isn't going to tell you to use the box. What I am doing is giving you additional instructions. I want us to practice with this box, okay? Again, on the tests, box is not mandatory, but I want you to practice with it enough so that you can make a decision about whether or not you think it's worth using. All right, so the activities here. We did a bunch of number 1 last time, so you guys are starting on number 2. Raise the flag if I can help.